Okay, I think we just about got away with that. So that's the elements acting as the oxidizing agents. Now the ions, F- and I-, these ones can act as reducing agents by donating electrons to something else. These were accepting, these were donating. So let's say I've got my something else there, and I've got an extra electron. It's meant to be a cross showing an extra electron. I've got my extra electron on my atom, and I'm going to try and lose that. That one this time wants to go there. Well, this time I've got my positive nucleus here, and just like my positive nucleus there, the same thing applies. That's very close to the nucleus, and we can think about shielding, so that's less likely to be lost. Less likely to lose that one. Whereas if we take the iodine, so iodide, so in this case we need to be careful with that. There's my electron, wants to fall off in the same way. Well, this time it's further away. So those sizes I've drawn are all things that you know already, but I'm just applying them to say, okay, how good are we at pulling electrons towards ourselves or donating electrons away? And you can see a sort of reverse relationship here. Iodine, very bad oxidizing agent, very bad at pulling that electron, but a very good reducing agent, very good at then losing an electron to something else. Fluorine and fluoride, the other way around, very good at accepting, very bad at donating. Okay, so that's the first thing to be aware of. We're looking at those two behaviours. Once we've looked at them, I'm going to stand that for a bit, kind of. Once we've looked at them, we're going to see the effect on sulfuric acid. So if I go back to some of the things from the starter, we're not going to look at the sulfate ion, that's that one. We're going to be looking at sulfuric acid. Now, the better the halide is at acting as a reducing agent, then the more the sulfur in the sulfuric acid will be reduced. If I dump a weak reducing agent into the sulfuric acid, I might get an acid-base reaction, but no further reactions. Dump a strong one in, and I'm going to get lots and lots of different reactions. Lots of reactions that all reduce the sulfur in the sulfuric acid in more and more. Okay, when you look at the oxidation states, it gets more and more reduced. All those reactions happen at the same time, and all of them are going to produce different products that you will see in the video. Sorry, in the PowerPoint. So your next jobs, once you've started following the PowerPoint and followed pages 1 and 2, you're going to find these grids of observations. And if I were you, I would do the grid as you see it in the PowerPoint, skip the questions. Do the grid, skip the questions. Do the grid, skip the questions. You need to be able to work out, or you need to be able to produce half equations and therefore overall equations for each of these types of reaction. You need to be able to do those in an exam situation. So with this topic and this bit of it, you've got two options. You can either get really, really good at doing the skill I showed you in the last video, not quite the last one, the first one I made, or you can just memorise the outcomes of these activities. Okay, you could just be memorising them, and they're not usually worth a huge amount of marks in an exam. Okay, so you might just want to memorise them, but whichever way you choose to do it, you need to be able to produce. If you're asked to state what is the give the overall equation for the reduction of sulfuric acid by this to form that, you need to be able to produce the equation either from working it out or from just remembering it. Now I'm going to make a little video in which I'm going to work one of them out using the technique I used in the first video. So with that one, I'm not going to have any audio at all. There'll be no audio. If you want audio, you can just play at the same time the video from lesson 1. or whatever I call it, the video where I balance the redox equation, okay? Because I'm going to use that exact method to balance, or to show you as an example, okay? But otherwise, you should be able to work through and write down your observations and work out some overall equations for the redox processes, okay? Oh, that reminds me, there were a couple more things. Yeah, mostly I've had very good engagement from you in terms of responding to what I'm asking you to do and sending me what you're up to. We're still waiting on quite a few people though, so I'm going to do a deal with you now. If by the end of the week I've had responses from 90% of you to the online lessons, then I will include in the video I make next a joke. A chemistry joke. Bear in mind I'm a bit of a chemistry nerd, so I find this funny. It's a story from something I was marking recently, not that recently. Okay? So if you want to hear my joke in one of my videos, please encourage your friends to get online and start doing the lessons. Thank you.